Exponential and linear growth. This is the fifth topic in the math theory section. Copy the title. Okay, so just like we saw in the interest formula, in the compound interest formula, we have the difference between being exponential and being linear. So exponential is about multiplying or dividing. So if multiplying is increasing, dividing if it's decreasing. Again, multiplying or dividing by the same number, so we can create the exponent, because remember, as I told you in the exponent class, an exponent is nothing but a multiplication of a number by itself. So the way in which we represent this is as a curve going up if it increases, or a curve going down if it decreases. Now, a linear growth or decrease will be formed by adding or subtracting, and is formed like a line, that's why it's called linear, going up, or a line going down. Pause the video right now, copy everything you see, and we're going to move on. So we're going to give some examples of exponential and linear. So exponential is multiplying or dividing, right? So let's say we have this. The number of bacteria, usually the DSAT deals with bacteria or virus or something, in a petri dish duplicates each hour. Duplicate means times 2, multiply times 2. So if the first hour is n, the second hour is 2n, then 4n, then 8n, and you can see how you start creating the exponent, because this is n, then this is 2, this is 2 times 2, so 2 squared, this is 2 to the cube. So at the end of the day, by the time you have reached t hours after these hours since the beginning, it will be 2 raised to the power of how many hours have passed. So this is your exponential, in this case, exponential growth. In the case of the linear, it will be created by adding or subtracting. So let's see a case. We have every day a person runs 2 more miles than the day before. So it's 2 more, it's added. So the first day we have n, then n plus 2, then n plus 4. And at the end of the day, we have n plus, and then 2 times, because 2 is the constant number that we're adding, times the number of days in which we began, right? Because it's 2 times 1, and this is 2 times 2. But if you notice, we're multiplying times a different number each time, so we don't really create the exponent. Okay, pause the video, copy everything you have to copy, move on. We're going to do an example. I want you to do this example. Pause the video right now. All they're asking you is to find whether this is going to create an exponential or a linear, either growth or decay. Okay, pause the video. Now we're going to solve it. So let's read the question. Jamie owes Tina some money and decides to pay her back in the following way. Okay, so Tina receives $2 the first day, then 6, then $18, and then $54. And then the question is, which of the following represents? First of all, we can see that the number of dollars, or the amount of dollars, is increasing, so everything's going to be increased. So any alternative that says decrease or decay, we're going to eliminate it. Now, is it linear or exponential? Just by looking at it, you kind of can tell that it's linear, but we still have to make sure. So let's see. In order to make sure whether it's linear or exponential, we first try to find whether there's a linear pattern. Okay, it will be 2 plus 4 gives you 6, but 6 plus 12 gives you 18. So I'm not finding the linear pattern here. What happens if I try to find the exponential pattern? So 2 times 3 gives you 6, 6 times 3 gives you 18, 18 times 3 gives you 54. So yes, I'm multiplying times 3 times 3 times 3. So it will be 2 times 3 raised to whatever power of time. How can you tell this? Because 2 is 3 to the power of 0, right? 3 to the power of 0 is 1 times 2 is 2. 6 is 2 times 3 to the power of 1. 18 is 2 times 3 to the power of 2. And 54 is 2 times 3 to the power of 3. Therefore, this is an exponential growth. So the answer is letter C. Okay, moving on. A scatter plot. A scatter plot is a graph in which, instead of having just a line or a curve, we have different or separate amounts of data. So we have just loose amounts of data. This happens like in real life, because data doesn't always follow a pattern. But you can see like a general pattern, maybe not a specific pattern like forming a line, but we can see whether the pattern is going up or down. So when you have a positive association, it means that the pattern is overall increasing. When you have a negative association, you can see that the pattern overall decreases. Pause the video, copy this. We are going to move on. Okay, we're going to do some questions. We're going to do question number 1. As I told you, the SAT loves bacteria, virus, or things that can pretty much grow exponentially. So I want you to solve this question over here, pause the video, solve the question. I'm going to solve it. You can use your calculator. Okay, write down your answer, of course. Okay, so we're going to start understanding. Bacteria are growing in a liquid growth medium. Okay, there were 300,000 cells per millimeter during initial observation. So the initial is this. This is my initial. Okay. The number of cells per millimeter doubles every 3 hours. Okay, so it's going to be times 2. Every 3 hours is times 2. So which means at hour 0, then at every 3 hours at hour 3, and then every 3 hours at hour 6, and so on. And the question is, how many will there be after 15 hours? I'm going to do the short solution first, and if you don't get it, don't worry. I'm also going to do the long solution. The short solution is, how many cycles of 3 hours do I have in 15 hours? Oh, I have 5 cycles of 3 hours. Therefore, what I have to do is I have to raise 3 to the power of 5 because my time is 5, and I multiply my initial times that. So I have 300,000 times 3 to the power of 5. I plug that in into my calculator and I get the answer, which is D. Copy this if you have to copy. I'm going to solve it in the step-by-step solution. So I'm going to explain it, don't worry. So the step-by-step solution goes like this. This is very, very, very important. So let's say the number of cells doubles every 3 hours, right? So we're going to still do the same example, like hour 0, hour 3, hour 6, hour 12, hour 9. Sorry, I messed it up. Let me do this again. Okay, so we have hour 0, hour 3, hour 6, hour 9, hour 12, and hour 15. And what we want is the hour 15. In the hour 0, I have 300,000, right? After 3 hours, I multiply times 2. So you do this in calculator and you get a number, which is 600,000. Then after 3 more hours, for hour 6, you again multiply times 2, and then you multiply times 2 again, and you multiply times 2, and you do this like with your hand, step by step. So you had 600,000, and you get 12, and you get 24, and then you get 48, and finally you get 96, which is the answer. And you can do it, you can solve it doing it step by step. You can always do this type of questions step by step, but if you use your formula, you're going to be faster at solving them. But then again, it's not the only way. There's usually more than one correct way of doing a question. Okay, I want you to pause the video here, solve this question over here, write down your answer, and we're going to check. Okay, here again, this is from the digital SAT. They are just asking us to see whether this is increasing, decreasing, exponential, or linear, and we're going to start seeing. So each year, the value of an investment increases by 0.49% of its value the previous year. So it's about the previous year. Which of the following function best models? So here's the thing. Every time it has something to do with the previous year, we know it's going to be exponential, right? And they're already telling us that it increases. Let's do it by the easiest first. They say that it increases, so it's not going to be decreasing. It's either increasing exponential or increasing linear. Since the value depends on the previous value, by definition, is going to be exponential, and the answer will be letter C. Okay, you can see the answers here. And if you want to do more practice, you can do these pages from the Panda book or from the variance book. And we're going to continue with the next topic in the theory.